Hi, hello students. Today we will discuss under linear integrated circuits. The topic is IC 555 timer basics. So here we are going to discuss about what about IC 555 timer, the pin diagram and circuit details and block diagrams and function of the 555 timer ICs with a neat sketch. So here this is the introduction about 555 timer. So it is one of the most popular and versatile ICs, and it was introduced by scientists in 1970s, in the year 1970s. And this IC is a combination of both the digital as well as analog circuits, and it is popularly known as time machine because it is performing widely in the case of timing tasks, timing applications. Because of this, it is used for a variety of applications like ramp generators, square wave generators, frequency dividers, voltage controlled oscillators, and there are a lot of toy circuits. It is widely used. And this is the pin details of IC 555 timer. It is generally available with 8 pin. The first pin is ground pin. Pin number 2 is trigger. Pin number 3 is output pin. We are going to take the response. And pin number 4 is reset pin. Pin number 5 is control voltage. Pin number 6 is threshold. Pin number 7 is discharging. Pin number 8 is power supply. The power supply handled with almost 4.5 volt to 15 volt it will handle. Right. So these are the pin description of IC 555 timer. So this is already we have discussed about pin numbers and their pin names, and these are the purpose of individual pins. And what about the basics of internal diagram of IC 555 timer? It contains almost 25 transistors, 2 diodes and 16 resistors. The maximum operating voltage is 16 volts. The maximum output current is 200 milliamps, and best treated as a single component with required input and output, and this is used for multiple processing part. And this is the internal block of IC 555 timer. This is a complete schematic diagram. And see here, this is the complete schematic diagram of IC 555 timer. And here we have threshold comparators, and these are trigger comparators. In the next slide we will discuss about the individual block diagrams of IC 555 timer. This is the complete schematic diagram that you can understand about how many transistors, how many resistors are connected internally. So the first one is the threshold comparator, the second one is trigger comparators, the third block is voltage divider, and the fourth block is flip-flop, and the fifth block is the output part, right? So the first two this circuit diagrams for mainly comparator parts. Okay, it's an op-amp comparator, and the third part, this is vertical line, right? This is called as voltage divider, where 3 resistors are connected, the equal values of resistors are connected, and it will divide the voltage. And this is a flip-flop. We are using SR flip-flop, and this is the output stage, right? So it is the schematic diagram, and we are going to discuss about simplified block diagram of the schematic. Yes. So now we will discuss about the block diagram and its working principle. And this is IC 555 timer, and these are 8 pins. We will start from pin number 1 is common point, that is called as ground pin, and whereas pin number 2 is trigger, it will act as one of the input terminal of the comparator. And pin number 3, here we have the output pin. It is that the response will be taken from the SR flip-flop. And we have pin number 4 is the reset pin. So reset pin, we are going to clear the content. And pin number 5, we have here a control input. The control input is one of the input terminal of the comparator. And pin number 6 is threshold voltage. The threshold voltage is another input terminal of the one of the comparator. It is taken from the capacitor charging discharging point. Then we have pin number 7 is discharging, and where the transistor is connected. Whenever the transistor is switched on, and through this the voltage will be discharged. Discharging will start across the capacitor. And we have pin number 8, that is plus VCC, that is supply voltage. And through this VCC and the RA, RB, through this RA, RB, the capacitor will charge us. So the charging time and discharging time of the capacitor determines the frequency of oscillation of these timer ICs through this RA. Whenever the power is on, RA through RA, RB, the capacitor starts charging and discharging. And charging and discharging will be fixed between two voltage levels. One is 2 by 3 VCC, another one is 1 by 3 VCC. This 2 by 3 and 1 by 3 VCC are the drop voltage across these three equivalent resistor components. So these are voltage divider points. Each resistors are connected with the 5 kilo ohms, 5 kilo ohms, 5 kilo ohms, and this drop is 2 by 3 VCC. Another drop is 1 by 3 VCC, and the first comparator compares the voltage of the capacitor along with 2 by 3 VCC. That is across pin number 6 and pin number 5. The second comparator compares the voltage across the capacitor along with 1 by 3 VCC drop voltage of this point. So first comparator compares this voltage, threshold voltage, with 2 by 3 VCC. Whenever the 2 by 3 VCC is greater than this, the output will be low. When the threshold voltage is greater, then output will be high. Similarly, the second comparator, if the capacitor voltage is greater than this 1 by 3 VCC, then output will be low, and the trigger voltage across the capacitor is lower than 1 by 3 VCC, the output will be high. Whenever this second comparator output is high, it sets the flip-flop. In the first comparator, whenever the output is high, it resets the flip-flop. If it resets the flip-flop, then Q bar will be 1. If Q bar is 1, then we will take the output, that is, this LED will be switched on, because this is the high voltage point, this is the low voltage point, this is the low voltage point, this is the high voltage point. When the output is high, this LED will glow, and this LED will switch off. So instead of this LED, we can connect any device to measure the response or to watch the response, right? So I'll repeat again. If the first comparator is on, when it will be on? If the threshold voltage is greater than this 2 by 3 VCC drop at this point, so this will be on. So it resets the flip-flop. So Q bar will be 1. Q bar is 1, the output will be switched on. Output will be high, right? So at this time, what is happening? If the Q bar is high, then it is connecting to this transistor. Now this transistor is made up of NPN transistor, and whenever the output is high, and this makes the transistor switched on, and this will act as a closed loop. It will act as a closed switch, and through this transistor the capacitor will discharge, right? It will discharge. So discharging will occur up to 1 by 3 VCC. So see here, this is the voltage across the capacitor. So lower level is 1 by 3 VCC, higher level is 2 by 3 VCC. So your capacitor will charge and discharge between 1 by 3 VCC to 2 by 3 VCC. Within that, it will charge and discharging will be happening, and this time period will be determined by this RA, RB points, right? So this is the way the 555 timer will turn on, right? And because of this timing applications, this timer is used widely in different type of toys and timing applications, etc. And see, this is the truth table for SR flip-flop. This we know already. This is Q bar. The last one is Q bar. So when both the values of S and R are 0 and there is no changes, so it will show the previous values. And if both are high, then there is not determined. These values are declined. If the R value is 1, that resets, then Q bar will be 1. If sets, the Q will be 1, right? So in order to show this truth table, I have shown this in the truth table clearly. And these are the descriptions. Whatever I have told, I am explaining here. And see, this is animation part. See that how this capacitor is charging and up to what level it is charging. Once the charging is reached this 2 by 3 VCC, what is happening in the first comparator? Once the discharging is reached towards this 1 by 3 VCC, what is happening in this second comparator? According to this trigger on the first comparator as well as second comparator, how this flip-flop enables the output. Once the output is high, how these LEDs glow, right? So these are all I've shown with respect to this 555 timer. See, this is the capacitor charging, discharging voltages. So now the capacitor discharges. See, once it reaches 1 by 3 VCC, yeah, then what's happening? This will be triggered on. So it sets the flip-flop, right? So if you understand clearly about this animation, then the working principle, everything is very simple. Whenever the output is high, and this transistor will act as closed switch, and through this it will be discharges. So according to this operation, the 555 timer will be acting as two mode of operation. One is stable mode and another one is monostable mode, and bistable mode of operation also is possible. Thank you.